Good morning, guys. Today we're going to talk about or start talking about 8.9C. And so we've already learned about topographic maps, and now we're going to kind of apply what we understand that topographic maps show different elevations, different landforms on the earth, like canyons and mountains. And then we're going to apply it a little bit to satellite views. And then we're going to connect that to stuff that you learned in seventh grade with changes in the environment and how satellite views can help us monitor those changes in the environment that occur over time. A lot was not known about the Earth until we were able to get satellites up into space in order to look down on the Earth, to be able to see um, bigger areas of land from a different perspective. And so our satellite that we have up in space provide a very important um, database of information so that we can see large scale changes that are occurring over time. So what you see right here is a topographic map of the Grand Canyon, and we should know that the Grand Canyon is one of the deepest canyons or holes, I guess, if you want to be simple, on the Earth, and it was created and formed by the Colorado River eroding the land above it. So this whole area of land here used to be completely flat until the Colorado River started over millions and millions of years, has basically carved into the ground and eroded this land away, creating these very deep canyons. You can notice that when we get very close to the river here, that the contour lines become extremely close, showing that there are very steep changes in elevation. There's all kinds of other creeks and other waterways that are running through this area that also contribute to that erosion. So this would be a topographic map to kind of give us some perspective as to where the canyons and the holes are, and then where the flat areas are, because we don't see a lot of topographic or contour lines in these flat areas. So this is what the canyon, that same area, looks like as a satellite view. Again, kind of difficult to kind of tell where the areas are going up and where the areas are going down. But here's the Colorado River again. You can see some shadows here because based on where the sun is. So these are all areas where the water is at the lowest point. This would be a very flat area at the top. So this cliff right here would be going downhill. And it's in shadow right now, but this would be the other side of that cliff. So the canyon is created by the flow of water through it. So you can see some other flat areas, but you can see that there's some serious elevation changes here. This is the topographic map of the tallest mountain in the lower 48 states, not the tallest mountain in the United States, that's in Alaska, but in the continental United States, Mount Rainier, which is right outside of Seattle. This is a volcano. Again, you can see where the peak of Mount Rainier is, and you can see how the contour lines show elevation changes, and you can again see how steep some of these areas are as far as the elevation change and how quickly it is changing in the area. I don't really like this view, but this is a satellite view of Mount Rainier that's covered in snow, of course. But again, we can use satellite views like this to kind of see, and you'll see in a video later on, how the amount of snow changes over time in certain areas as well. Okay, this is a topographic map of Mount St. Helens. Mount St. Helens is also a volcano in the same state, the state of Washington, that Mount Rainier is in. But in 1980, Mount St. Helens erupted and exploded and removed the entire north face of the mountain. So if you look on the south, east, and west sides here, it looks like any normal mountain. There's a deep crater, so these are actually going downhill here in the middle. This is the new lava dome that's being created. And we'll talk more about volcanoes when we get back after Christmas. And then this is the breach. This is where things aren't as steep right here. And this is where all of the pyroclastic flow and ash blew out of the north face of the mountain. So this is, again, this is what the mountain looks like from space. Again, this big area right here is the big crater, where there used to be, used to look a lot like Mount Rainier. But again, the whole top of that mountain was blown off. Okay, so this is a topographic map of an area. I'm not really sure where, but you can see here we have, again, something that looks very similar to the canyon, that we saw earlier with the Grand Canyon, and this would be the satellite view of that same area. Again, some flat farmland. You can see the circles usually mean created by the irrigational systems that the farmers use. But again, if we go back, you can see how the topographic map kind of matches up with the satellite view of what you're seeing. Okay, so this is a picture of something that happened in Hawaii a couple of years ago, 2018. So this is a picture of an area called Leilani Gardens in 2014. And then there was a fissure that opened up in Hawaii because Hawaii is an active volcano that emitted lava from the volcano, and it opened up right here. And so you can see this whole area that exists here in 2014 no longer exists in 2018 because of this huge lava flow that wiped out that section. So again, this is another benefit of satellite views and how we can see those changes, those natural changes over time. This is a picture of the San Jacinto River. This is outside of Houston. This is very close by where we won independence, Texas, at San Jacinto. And you can see here, this is before a flood, and this is what that area looks like after a flood. Okay, so this is actually stitched together. So this was before the flood. This is the river kind of continuing right here. You can see how we can use satellite views to monitor the extent of damage of floods, and then use that data for the future when heavy rains come, so we have an idea of what could happen again, and so the people that live in this area can be aware of the dangers when we have hurricanes or other flash flood events. Okay, so this one is a little closer to home. This is Medina Lake, and I forget when this was taken, but I want to compare Medina Lake in this image. This is a more recent image to Medina Lake in the past. So, sorry, if we go here, we can see that before we had drought conditions here in San Antonio, that Medina Lake was really, really full. If you look at these areas over here on the left side, and these little inlets, these little bays where people will put their boats and stuff like that and own their homes. And so again, going back after the drought, when water evaporates out of the lake, you can see the drastic change in the water level in the lake. So all of these areas here that were filled with water before, and these areas over here that were filled with water, changed significantly because of the drought. So again, that's an environmental change that can be monitored with different satellite views. And so you can see that you can literally walk out into these areas of the lake, whereas before, when it was full like this, you can't. So you can see the changes in Medina Lake over time because of drought conditions. So I want to show you this video really quick. In case you didn't know, this happened earlier this year in Beirut. So these are all images of the same explosion, and this explosion occurred at a storage facility on the coast that created this huge explosion. Nitrogen phosphate, which was stored in that area, exploded, was stored improperly, and created this issue. And so this link here kind of shows you, and I like this one because there's like a little slider that shows you how the image changed over time. Um, so this is that area before the explosion. All of the fertilizer that exploded was stored in this building right here. Okay, so this is what that area looked like before. And then if I pull this across, this is what the area looked like after the explosion. So you can see that all of these buildings here were completely destroyed. There was a huge crater right here where the explosion occurred. Miraculously, this building right here stayed upright. But if we go back and see, these are some storage buildings, large storage buildings here. And you can see after the explosion how all of that got wiped out. So the ability for us to use satellite imagery to be able to see how things like this change. Now, this was a man-made mistake, but again, the satellite views bring a lot of information to us about what the effects of these changes are on the Earth. Okay. And so this is another image of showing you how drought conditions can change the size of a lake. So you see here again, we have this lake here. We can see a color change, which usually means that there's an algae issue as well. And then here, the lake is almost completely dried up. Okay. And so we're going to go ahead and watch this really quick. Again, you can see the changes of the RLC. Here, let me do it again with sound.
Before and after images demonstrate how quickly our dynamic but fragile planet can change. The Aral Sea in Central Asia was once the fourth largest lake in the world. In the 1960s, the Soviet Union began using it to help grow crops. These images were taken just 14 years apart. Losing the moderating influence of this large body of water has made the region's winters colder and summers hotter. In 2011, NASA captured a new volcanic island emerging in the Red Sea off the coast of Yemen. It's part of the Red Sea Rift, where the African and Arabian tectonic plates meet. The island's chain gained an additional rock in 2013 that doesn't even appear in this photograph. By tapping water sources beneath the sands of Saudi Arabia, engineers turned the desert into an oasis. But with only 50 more years of groundwater supply left, the clock is ticking. Farmers could survive, though, by switching to greenhouse farming with drip irrigation. The Muir Glacier in Alaska has been documented for 120 years. Named for Scottish naturalist and writer John Muir, the glacier used to fill this entire inlet. This photo taken in 2004 shows how warmer temperatures have caused its shocking 31-mile retreat. It may seem like a winter wonderland, but many of Yellowstone National Park's 2 million plus acres are now prone to wildfire. Longer, drier summers are a big problem, but this 2016 image actually shows how Yellowstone has recovered from the 1988 fire that consumed more than half the park. And in 1984, Brazil plugged the Jamari River with the Samuel Hydroelectric Dam. The reservoir it created flooded the upstream forest. The image on the right also captures the effects of deforestation that could cut the Amazon to just 47% of its original size by 2030. The Binhai new area in China, now a manufacturing powerhouse, was once salt farms and marshland. As you can see, the growth, which began in 1990, has extended into the Bohai Sea and is only expected to continue as the area becomes integrated into the Jing-Jin-Ji megalopolis. This delta, where the Omo River meets Africa's Lake Turkana, used to be contained entirely within Ethiopia, but it's grown so big it's now located mainly in Kenya. It's expanded as the lake's water level has been reduced by less rain, higher temperatures, and agricultural activity. And here we have an extremely remote area in the harsh conditions of Kazakhstan near the Caspian Sea. which shows the development of production facilities to take advantage of oil and gas deposits. Those settlements you see are to house workers, which demonstrates the lengths humans will go for a good paying job. And then we have Iran's Lake Maya, which changed color from green to red in a matter of weeks last summer. The culprit, a combination of algae and bacteria that causes the change when the weather gets hot and the lake begins to evaporate, increasing its salinity or saltiness. Well, I hope this gave you a little more appreciation for the natural world surrounding you wherever you find it.
Okay. So that's where our discussion is going to lead us over the next couple of days. Remember that if you have any questions, make sure you ask. The 6 weeks ends, or the grading period ends this Friday. So make sure that you're getting into Schoology and getting that work done. All right, guys, y'all have a good day.